Hi everybody, I'm Greg Fishel. Welcome to bonus weather video number 3 for this week. And yesterday we talked about the gases that make up our atmosphere and some of the properties of those gases. So I thought today we'd follow that up by taking a look at the different layers of the atmosphere and how thick they are. And in the end, I think you'll agree with me that it's pretty remarkable how thin this protective atmosphere is compared to the size of the Earth. And it's really hard to believe that, at least to me, that this all happened by accident. But that's open to opinion. So let's go on ahead here and get started. And we're going to talk about each layer one by one. Now, the troposphere is virtually where all the weather occurs, okay, where we live. So that's the part of the atmosphere that meteorologists are most concerned about. On average, it's about 12 kilometers thick or about 7.5 miles in height. And it is taller at the equator and shorter at the poles. And the reason for that is that the air at the poles obviously is colder, it's more dense, and so it occupies less space, whereas at the equator, where it's much warmer, then it is much taller. So on average, 12 kilometers, 7.5 miles, but a little lower at the poles, a little higher at the equator. 99% of all water vapor and aerosols occur in the troposphere, are present in the troposphere. Temperatures go down on most times as you go up, since most of the heat found in the troposphere comes from the transfer of heat from the Earth's surface. The atmosphere is nearly transparent to incoming solar radiation, but the Earth absorbs that radiation, re-emits it as infrared radiation, and heats the atmosphere from the bottom up. So we think about the sun as being the source of heat, and ultimately it is, but it doesn't do it directly, okay? It heats the Earth's surface, and then the Earth's surface then re-radiates that heat at a different wavelength, and that's what heats the air from the bottom up. It is the densest atmospheric layer by far, and most clouds are found here. There are a couple of clouds that can be found in the stratosphere, but not many. Okay, the stratosphere is located between 12 kilometers and 50 kilometers, or about 7.5 miles to 31 miles above the Earth's surface. The ozone layer resides here, and it protects us from harmful ultraviolet radiation, and the temperatures in this layer actually increase with height. Now, this layer is a great example of how man can alter a trend which is not good. You may remember the ozone hole being a significant problem many, many years ago, and then through the reduction of chlorofluorocarbons, that hole has shrunk in size. So it is an example of how man can indeed modify his environment if he sees a problem cropping up. Now, above that is the mesosphere. It's located between 31 miles and 50 miles above the Earth's surface. Here, the temperatures go back to decreasing with height. And here is where we find the coldest temperatures in the Earth's entire system, with temperatures at the top of the layer as cold as minus 90 degrees C, which is about minus 130 Fahrenheit. And most meteors burn up in this layer. And you're probably asking yourself, well, how the heck can they burn up if it's 90 degrees below 0 Celsius or minus 130 Fahrenheit? Well, this is the first layer where meteorites encounter any air molecules at all. And so as they move rapidly into the mesosphere, they compress the air, and that compression causes ridiculous amounts of heating. It can get up to as high as 10,000 degrees Fahrenheit, and most meteorites are not going to be able to tolerate that. So even though the average temperature is that cold at the top of the layer, that air compression heats the air dramatically, and the meteorite then burns up. Okay, now we move on to the thermosphere, which is located between 50 and 440 miles. So this is a very deep layer. There's just not a whole lot of air in it. The lowest part of that contains the ionosphere. Temperatures increase with altitude again. So you notice we have decrease, increase, decrease, increase so far. And the International Space Station orbits the Earth in this particular layer. And then finally, the exosphere, where there's basically, very, very little breathable air. It's located between 440 miles and 6,200 miles above the Earth's surface, and most of the Earth satellites orbit in this particular layer. So it just gives you a general overview as to these 5 layers of the atmosphere and what goes on in each one of them. So looking at this graphically, let's take a look at the comparable depths of these different layers. Now, the troposphere is actually very, very thin, okay? It only, again, on average is about 7.5 miles in height, again, a little bit higher at the equator than at the poles. And then above that, we have the stratosphere, which is a little bit less dense, occupying a little bit more depth. And then we have the mesosphere above that, okay? And then look at this. The thermosphere goes from 50 to 440 miles up. So it is much, much deeper than any of those prior 3 layers. But the thing is that there's very, very little air in that particular layer. So yes, it occupies a great depth, but there's not a lot of substance to it there at all. And if I were to put the exosphere on here, it would have gone way off your screen, okay? So again, that can go up to 6,200 miles out, where there may be one molecule of air present if somebody goes really looking hard for it. And there's the exosphere stats right there, 440 to 6,200 miles above the Earth's surface. All right, there are your credits. That is the bonus weather video for this Friday. And the daily weather update, of course, will be coming up a little later. And I hope you have a wonderful Friday evening, an even better weekend, and we will talk to you again on Monday. And by the way, I just want to remind everybody that I will be departing with Festive Brass at Myrtle Beach out of the Charlotte airport on Tuesday afternoon. I shouldn't have any problem getting anything to you on Monday, but Tuesday we're going to be in the air at about the time that I normally produce this. So Tuesday's a question mark. And then for the next 7 days after that, we have an itinerary that is absolutely stacked from top to bottom. I will do my best to get something to you. If nothing else, I want to share the experience of being over in Normandy and Paris and so forth with you. I just can't promise you detailed weather updates for that 7-day period that we're going to be over there from June 5th until June 12th. I'll do my best, and I'll, hopefully we'll have Wi-Fi and all that kind of stuff, and I can at least get something out to you. So please bear with me during that period of time, but hopefully I'll be able to get you some good stuff so that you can share in the enjoyment of this trip. All right, folks, that's it for now. You all have a wonderful Friday evening, and we'll talk to you again Monday. Take care.